Hello, my friends. It's the NOLA Mathman coming again for another fun math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After watching this video, students will be able to compare sets of data using the various interpreting methods that can occur with statistics like this. The concept we're looking at is statistics and probability. The skill we're looking at in this particular section is comparing sets of data using the various modes of comparison. So with no further ado, let's get into our lesson. So in this problem, we're finding the mean, median, mode, range, and standard deviation of each data set that is obtained after adding a given constant to each value. So we will learn how to do that today. So it said here, the set of data after subtracting 7. We're going to do number 2. So before we find mean, median, mode, range, and standard deviation, we're going to change the values by subtracting 7 from each above data point as they suggested for us to do. So it's going to change our little table. So instead of having 57, we'll have 50. Instead of 38, we'll have 31, and so on and so forth. So the new set of data points will be 50, 31, 35, 44, 32, 37, 26, and 48. And so each of these are determined once you subtract 7 from the original values. So now we have to find these 5 components that we use for statistics for these data points. So mean is the first one, and that's the one most people are accustomed to. We simply add each of the data points and divide by the total number of terms. So since these are, we have a total of 8, we add the 8 terms together, divide by 8, and we will get a mean average, which is that little X with the line over it. That's how you want to signify it. We don't have to write that, we just say the mean. So the mean in this problem will be 37.87. So that's the average of those 8 data points. So now the median, how do you determine median? Well, median is determined by finding the middle term. So what I'm going to do is rewrite each of these 8 data points from the lowest to the highest, and then we're going to find the one that's in the middle. If there are 2 in the middle, then we take the average of the 2 in the middle. So since we have an even number of points, we'll have 2 median values and we'll find the average. So you'll see what we do. We just, cancel off the ends and the ends, and we keep working our way in until we get to the median. So the median will be the average of the 2 terms, 35 and 37. That's equal to 36. And so the median in this problem is 36. Now the mode is a term that appears the most. So there is no mode because none of those terms appear more than once. That can happen, so in this case there is no mode. And that is what the NOLA Mathman is putting down, writing down why there's no mode, because there's no data point that occurs more than once. So next we want to do the range. The range is easy. That's why it's good to write it from the least to the greatest, because you get the range by subtracting the largest term in the data points from the smallest, and that's equal to 24 to 50 minus 26. So now we want to put our data points above there, and we want to write our mean. And now we will use all that information to get our standard deviation. So we're going to follow steps like we did in a previous video. And so step 1 says find the mean. We already have calculated that. That is equal to 37.875. Step 2 is we must find the squares of the differences, I think, between the mean and each data point. So it says here, find the squares of the differences. Again, between the mean and each specific data point, which is x minus x bar, whatever above, minus x to the n squared, which we had done in the previous video. So we have to do that for each of the 8 values. First data point is 50, so we take the mean, which is equal to 37.875 minus 50, and we must square that. And whatever that equals, that is the square of the difference. So again, you get your calculator out. That will give us 37.875 minus 50 is negative 12.125. You square that value and you will get 147.02. I'm rounding to the nearest hundredth, which is 2 decimal places. You can round it any way you want, but I'm rounding to the nearest hundredth, 2 decimal places. So next data point is 31, which is the second point. And we must find the square of the differences for that. So we will write 37.875 minus 31 squared. And so when we do that, we will end up with a value of 6.875 squared. Again, you do all this on a calculator. And we will get a value of 47.27 rounded off to the nearest hundredth place. Now we do it for the third data point. And so we do the same calculation over and over. And so we take the mean, which is 37.875, subtract 35, and you square that. And when you do that, you will get, I believe, 2.875, and you will square that. And when you square that using the calculator and round it to the nearest hundredth, you'll come up with 8.23. So now we gotta keep going. We put our fourth value, data point, 44. We take the mean and subtract from that and square it. And so we will have 37.875 minus 44 squared. Now this stuff is very tedious, so it's very important that you organize your work, you have it nice and structured, because when you do a problem like this, it takes a lot of different steps. You have to organize a lot of material. So for this example, we have negative 6.125 squared, rounded to the nearest hundred, 37.52. And again, we have to do this for 8 values, so this is going to take a minute. So now we're going to do the fifth one, 32, and we got 30, the mean, 37.875 minus 32, and that will give us 5.875 squared, I believe. Let's see what the NOLA MATHMAN comes up with. And yeah, that's what it looks like. And then we're going to square that and round that answer to the nearest hundredth place. And that will be 34.52. So we have another one here at the bottom here, 37. So we subtract the mean from that value. That's 37.875 minus 37 squared, which is going to be 0.875 squared. And that will get us a value of, let's see what the NOLA MATHMAN, use your calculators, 0.77, which again is rounded to the nearest hundred. So So now we have our 7th data point. We have to do that for, which is 26. And we're going to have basically the mean of 37.875 minus 26 squared. And what does that equal? Use your calculators. That equals 11.875 squared. And that's going to give us a value of 141.02. We have one more data point left. X8. Again, we're going to subtract the mean minus the 8 data points, square that. That'll give us 37.875 minus 48 squared. And that will give us a value of, that'll be negative 10.125. We're going to square that, round it to the nearest hundredth. We'll get 102.52. So now we have gotten all the differences of the squares of the differences. And all those values. And step 3 says to add all these values we've just calculated together. So we have 8 squares of differences that we're going to add. You can see there at the bottom, that is what the NOLA MATHMAN is doing. And so I'm going to take each of those values we've just calculated for each of the 8 data points, and we're going to add them together. And again, you will need your calculator to do this. And when we add them, we will get a value of, let's see what we get here. We run the points here, we're adding. We're almost done here. It takes a lot. And so we will get a sum of, I think it's 518.91. We're about to see it pop up because step 4, you must use it to find the variance value, the variation value. So I call it, which is the little sideways piece squared, which is going to equal the sum 518.91 divided by the number term, which is 8. And so that will give us the variation, I'm sorry, I don't know why I said variance. The variation, which is 64.86. So now we're going to take the square root of that value to get our standard deviation, as we did in the last example. I mean, not in the last example, but one of the other videos we did that. So we're going to say find the standard deviation. We're going to take the square root to get the standard deviation, the square root of our variation value. Because if you want to get that little sideways p, you take the square root of the variation, which we want. I didn't round it because we want to get as exact a value as possible. And so we take the square root of that. We will end up, and we want to round that to the nearest hundredth. 8.05 is the standard deviation. So that was pretty good. So now we're going to do another one, but this time instead of adding and subtracting, we will multiply each value by the given constant. So the way you do this is we don't change the data points right away like we did with subtraction. We're going to actually do the mean, median, mode, and range for this particular bit of data we have. We're doing number 8. I'm sure the NOLA MATHMAN will circle in a sec, but we're going to do the mean, median, mode, range, and standard deviation for the original set of points. And to get our new value by multiplying, we'll just multiply all those values by 2. So that's the method we're going to use. So in this first example, we add the 9 terms up. We divide by 9. And so the mean for number 8 will be equal to 53.67. and that is the average of all those data points. The median, again, we're going to list the values from lowest to highest, and we're going to find what's in the middle. And so since we have 9 values, or odd number of values, the median is going to be the one term in the middle, which we're going to find in the set once we pair off the ends and keep working inside till we get to the middle. So that's the method you want to use in calculating the median. We're listing them from least to greatest. Now we have all 9 terms, and we're going to work them in, taking the ends out, and we'll be left with one term in the middle, which is 55. And so the median of this 9 terms of data will be 55. Now the mode is the term that appears the most. In this problem, 50 occurs 3 times. So the mode is the most frequently occurring data point, and that would be 50. The range, you take the lowest value and subtract it from the highest. So 58 minus 50 is 8, and so the range is 8. So we write those values up there. Now we want to find the standard deviation for this particular set of data. And again, we must follow all the steps we did in the previous example. And so this is going to take us a minute, but that's fine. You want to be very thorough and detailed, so you want to be very important to have your stuff structured well and organized very well. So we already have the median, so we did step 1. Step 2 in the process, let's see if y'all remember. What is step 2? Let's see, we just did it. Let's see if you remember. Yeah, you're correct. It's to find the square of the differences between the mean and each term. You're correct. So we're going to find the square of the differences between, again, x bar, which is mean, minus each term squared. So the first term here is 55, and so we're going to find the square of that difference from the mean 53.67 minus 55 squared. And when you solve all that, again, you get your calculator out. You're going to do the subtraction and the grouping symbol first. You're going to get a value. Use your calculator for that. That would be negative 1.33. Then you will square that value and you will get the square of the difference. And that will be 1.7689. So in this problem, instead of rounding to the nearest 100th, 2 decimal places, I'm rounding to the nearest 10,000th, which is 4 decimal places. Now, what does this do? Why do you do that? Well, it will make the answer more accurate. So the more decimal points you include, the more accurate your answer is. But you can do 2 decimal places also. So in the second example, we end up getting a square of 13.4689. And so, you can see here the NOLA MATHMAN are subtracting the mean from the term and then squaring it. Pretty self-explanatory, same concept. Be careful with the arithmetic, and you should be able to get the right answer. In the third group, we have a difference of negative 4.33. We square that, you will get 18.7. I can't really see that term, but you can see it, so it'll pop up here in a second when we adding our squares together. So we now have 52. We're in our 4th data point. And so we take 53.67 minus 52 squared. That'll get us 1.67 squared. Again, we want to round that for the 4 decimal places. And that will get us 2.7889. Now we go to the 5th one. That will be equal to 656. That's the 5th data point. We follow the same process. very tedious. You gotta really take your time and get into it there. Can't make any silly errors. You gotta be very detailed with your work. And in this next group of differences, we get negative 2.33. We square that, and we will get a square of 5.4289. And we'll do the sixth one. 6 data points, 57. We want to substitute that in. And so we put 53.67 minus 57 squared. That will give us a difference. It'll be negative, I'm sure. Negative 3.33 squared, which will give us a value of 11.0889, I believe. So now we're on the seventh value. Now, 7 has already been done. So, because we've already had a value of 50. So it's not like you need to calculate this. We can just take the value we had from the other square when the data point was 50 and just write it. I'm just writing the steps of substituting the value in, but you shouldn't have to calculate it again. The answer is going to be 13.4689 because we've already done an earlier value, which was the second value. And so for the 8th data point, which is 55, we just did that also when we did our first data point of 55. So we can use that same value of just plugging in the formula, but we don't have to calculate it. We already had that value. So we're going to write that down, which is 1.7689. And then for the 9th data point, which is 50, we already have that written right here on the screen. So we will write 13.4689 for that. Now I'm just substituting the values in because we want to use that process and be consistent in showing the work thoroughly. Yeah. But as you can see, it's the same data point, so you can have the same square. So now we've calculated all the squares, so we want to get our standard deviation. Step 3 is to find our variation, I believe. Let's see if that's what it is. Oh, we got to find the sum first, then the variation. So we take all the values of the differences, the squares of the differences, and we're going to add them together and get one big sum. So that's what the NOLA MATHMAN is doing here. We're writing the 9 squares down, and we're going to add them all together. And we're going to get a sum. So again, get your little calculators out. As the NOLA MATHMAN is calculating it on his calculator, you want to be doing the same thing so that you can get the same answer, and that will build your confidence even before you start doing the problem if you work along with the NOLA MATHMAN. So we'll add all these values up. We have 9, so it takes a minute to write them all. I think this is the 9th one here. And so you plug that in the calculator, and we will get 82.001. Almost 82. Very close to 82, that's good. Maybe it's because we use the 4 decimal places, maybe more exact, I don't know. It's a good question. So, but the answers will be really close, so even if you round it to the nearest 100th or 1,000th, it shouldn't matter. So now we're going to find the variance by taking, I said the variation, it's actually a variance. I put in the last problem variation and variance. I wrote that wrong. So we're going to take the sum and divide by the number of terms, and the variance is equal to 9.11. And you know, we're going to write it out so we can write as many digits as possible. So when we take the square root and we round it to the nearest 100th, it'll be as exact as possible. So the last step is we're going to find the standard deviation by taking the square root of the little sideways p, which we call the variation. We take the square root of that, and we will get our standard deviation for this set of data. And so that's what we're gonna do. Now we're not done because we still have to multiply by 2, but we will finish this original set of data. So we substitute square root, we take the square root of 9.1111, 22222, and that will give us a standard deviation of 3.02. So now we have the mean, median, mode, range, and standard deviation, which are right here in the top, right here in the corner of the problem. And now, and I rewrote it again here. And so now to get the mean, median, mode, range, and standard deviation for the new set of data, after multiplying by 2, we multiply all these values by 2. So our new mean will be 107.34. Our new median will be equal to 55 times 2, which is 110. Our new mode will be equal to 50 times 2, which is 100. Our new range will be equal to 8 times 2, which is 16. And our new standard deviation will be 3.02 times 2, which is going to equal 6.04. Which we'll pop up here in a second. So again, we have now gotten our answer. The NOLA Mathman circles the answers, make it clear to the viewer. And so we have done another fun lesson on the various components of analyzing data. We've mastered it. We've done various examples. You should feel much more confident as you address your concerns and challenges with your own problems associated with this concept. You should be way more confident and clear. And so until we meet for another math adventure, it's the NOLA Mathman signing off. Have a blessed and prosperous